So say you have a data set that depends on time, and you want to evaluate the performance of a model that you've built to generate forecasts. How exactly can you go about doing that? We could try cross-validation. However, we have to be careful about that, because if we just split up our data into folds and test those, we risk having data leakage. We can't do this because of the dependence on time. So what are we going to do in this case? Well, we're going to make use of what's called time series cross-validation. Now in this video, we're going to cover time series cross-validation. First, I'm going to illustrate what exactly time series cross-validation is, and I'll walk you through a simple visual example to convey these ideas. And afterwards, we will jump into a Jupyter notebook where I will show you how we can actually implement this type of cross-validation in Python. So without any further delay, let's jump into the content of this video. Now, the data we're going to be using in this video is the air passengers dataset available from stats models. Now here you can see a rough illustration for what these data look like. Now, we want to be able to build a model in order to generate forecasts. How exactly can we do that? We have this time dependency, and that restricts us from using ordinary cross-validation. Again, as mentioned earlier, we have to be careful about data leakage. And so we can't mix past and future data points. Time series cross-validation involves using multiple folds like any other cross-validation, but where the training set expands and moves forward in time. We're always testing on data that is then later in time. So you can see that illustrated here for fold 1. Training goes up until 1952, and the testing happens for the following year. We can build a Sarima model and then generate forecasts over the test set. You see that in yellow. And now we can compare the forecast with the actual data using a metric like the root mean squared error. With this, we can then evaluate how effective our model is at generating forecasts for that particular fold. Now we go to fold 2, and you can see here we extend it out. We now incorporate what was previously the test data for fold 1, and now that part becomes part of the training, and we test over the next year. So this is the general process, and we proceed through all of the folds in our procedure like this in order to generate a set of results that we can then average over to get a more robust and generalized assessment for how well our model is at generating forecasts on the data we have. So I hope this conveys the general idea for what is going on and how do we actually do time series cross-validation. Now let's jump into a Jupyter notebook where I will show you how to implement the ideas we just covered here in Python. So now we're in a Jupyter notebook, and you can find a link to this notebook in the description below. This notebook is available on my GitHub, so you can download it and work through the example we'll cover here yourself. So now let's go to the section at the bottom that I have added for time series. And you can see here that we have an initial cell where I'm importing all the packages that we need specifically for the time series example that we have. So let's just run this cell. Okay, and now what we can do is load in the air passengers data set. Now we get this from stats models, and we just load in the data here with our first command. And then we can format the date just so that we get proper dates at a monthly level. So that's just what this code is doing here. And then I'm also setting the index and then the index frequency properly, and this will just help us with plotting the data in the subsequent cells. So let's just run this. And now let's plot the data. It'd be nice to see this. Okay. And yeah, this is looking pretty good. The air passengers data set is actually one of the more popular data sets available for anyone working on time series models or trying to test out a different time series algorithm. So here what we clearly see is that what we have on the horizontal axis, we've got time. So this is in years ranging from 1949 and it goes on beyond 1960, so it's like 1961. And then the vertical axis is the number of passengers. So we immediately notice in this data that there's a clear trend. There's a positive trend as time passes. The number of passengers tends to increase. But we also notice that there's this sort of like this sawtooth pattern. It's a seasonal component that happens every single year. So there's some point in the year where the number of flights that occurs really spikes and then it sort of dips back down again. So we can see this repeating pattern. And as a result, the choice of model we're going to use here for this example is a SARIMA model. It's a pretty common time series model for seasonal data. So that's what we're going to use. Now let's set things up for the cross-validation procedure. So I'm going to be making use of this time series split function that's available from scikit-learn. We imported that already above. And we can use this function to get proper splits of our data. So we can specify how we want the data split by the arguments we have here. I'm specifying that I want 5 splits and I want the test size or the size of the test set to be 12 or 12 months, right? Because remember up above we formatted the data to be at a monthly level. Now what time series split is going to do is it's going to generate splits, but it's going to pay attention to the chronology. It's going to pay attention to the time component of the data. So we're always going to have training data that comes before the test period. That's very important. That's what this function is doing. So we can run this cell and it just specifies here that the number of observations we have, number of months is 144. And again, the number of cross-validation folds we have is what we specified. That's 5. Okay, so the actual cross-validation is going to happen in the next cell. So let's walk through each component of this cell one by one. So the first thing that I'm doing here is I'm specifying the parameters that we're going to feed into our SARIMA model. The only parameter of real interest that we set here is just with the seasonal component. We're setting that to be 12, and that's just because we see that there's a annual seasonal component to the data. Otherwise, I'm setting everything to be 1. So it's just a very simple SARIMA model. Now we iterate through all the splits that we computed previously up above using time series split. And then with the indices we obtain from that function, we can extract out the training data and the test data. We can fit our SARIMA model, and that's what we get here from stats models. We can fit it on the training data. That's what we see here. Notice that I'm setting the number of iterations for convergence up to 200. And then with the fitted model, we can generate a forecast. And the forecast we're setting here, the number of steps I want to go out in time is the length of the test set. So in our case, the steps parameter is just the number of months that I want to have forecasts for from the point where our training data has terminated or ended. So once we have the forecast, we can then compute the root mean squared error between the test and the forecast we get. And afterwards, I'm going to store the results just in this list here. So in fold results, we can store everything. And then I'm just going to print out basically some information at the end. So, okay, we now have an understanding for what is going on in this cell. Let's run it. And I didn't import NumPy, so let's go back up. Let's do this. Okay, this should work now. Okay, so now we have the results, and we can see here that for the different folds, in general, as we proceed in time, we see that the error gradually increases. The one exception is with fold 4, where it seems like we get a real spike. So there's a real divergence in between the forecast and what the actual data is. So if we then look at what the mean of our results is, we have basically, on average, we get a root mean squared error of 22.5. So, okay, this gives us a fair sense of how our model would perform on unseen data. So it's a good generalized result. Let's visualize these results a little bit. So we can run the next cell just to iterate over and plot the forecasts over the actual data. So let's take a peek at how our Surima model has actually functioned. So here you can see the same data that we saw previously, and superimposed on it are the forecasts for the 5 different folds. So you see the first fold starts off here with the predictions in orange, and then we have fold 2 in green, and then so on and so forth. So you can see in general, our model is actually done pretty good. These predictions actually look pretty reasonable. The only one that seems to be off is for fold 4. Here you can see it has generally the correct shape, but it seems to be translated down with respect to the real data. So we can probably fix this by just playing with the parameters that we feed into the Surima model. As mentioned, this video is just meant to demonstrate how to do time series cross-validation, but if you want, you can always play around with those parameters to see if you can get better results. So in general, this is how our model is doing, and it visualizes the cross-validation process. And now we can also just tabulate our results. So the last part of this notebook just shows for each of the folds our training period. So we see that the training start time is always fixed. It's at the beginning of 1949. The training end shifts by 1 year as we proceed from fold 1 through to fold 5. And correspondingly, the test period also shifts over by 1 year. So the total length of the test period remains 12 months, but it's always moving forward in time with respect to the training data. And here I've also outlined the results for each of the folds. This concludes the video. I hope you can now walk away with a good sense for what time series cross-validation is, why we do it, and how you can implement it yourself for your own projects in Python. So if you liked this video and got some value from it, please like, share, and consider subscribing to the channel. Your support is greatly appreciated. Have a great day, and I'll see you in the next video.